Okay, so we are going to learn some terminologies. Here we have tree structures, right? It's a big tree structures. And then some terminology here is first, edge, and node. So we have been talking about this here, this thing as a link and edge and line or reference. So here in this diagram, we are going to call it edge, right? And this is going to be called node. And this is simple one, right? And our next thing is the root and root. And mother of all things, this is the first node, and this is where it starts, and the root is really the first node, okay? And the next thing that we want to know is the, okay, A is this parent, and D is A's child, right? And here, B is A's parent. A is B's parent, sorry, and B is A's child. And B is E's parent, and E is A's child, right? B is E's parent, and E is B's child. And we have siblings, right? We have a mother and father parents, and I have one younger sister. I personally have, and you might have multiple siblings or just one siblings, and you might have no siblings. But with a same shared parent, these children are siblings, right? E, F, G, H are siblings with the parent of B, right? And suppose B, C, and D are also siblings, right? Great. And we are going to call internal nodes, A and B. These are no leaves. Leaves are the nodes at the end of these tree structures, E, F, G, H, and C and D. There is no next of these nodes. These are called leaves, and also these are called terminal nodes. And if one node is not leaves and terminal nodes, they are internal nodes, right? And the second terminology is this. D is descendants of A. Of course, B, C, D, E, F, G, H are descendants of A. And E, F, G, H are descendants of what? B, right? Very simple, right? And E's ancestors are A and B. F's ancestors are A and B, right? And H's ancestors are A and B. How about D? These ancestors are actually is A. And path to E is like this. So path is a root, right? Root, where you start and where you end. And root A is always the starting point. Okay? And this E is where you want to get. And path to E is A to B and B to E. That's the path. Path to H is A to B and B to H. Path to D is A to D, right? Here, I want to ask one more question, right? One more question is that, is there multiple way to get to any of these nodes? Is there any nodes have multiple passes? Is any nodes has multiple passes? Your answer is no, right? Each node has a unique path. That's the key characteristic of the tree structures. Nodes in tree structures have only one path from the root, right? There is only single root from root to that node. There is no nodes have multiple passes in at least tree structures, right? Right. And let's move on. So depth and level of B. So A steps is 0, B steps is 1, E steps is 2. C steps is 1, D steps is 1. F steps is 2, G steps is 2, H steps is 2. If these nodes share the same depths, they are at the same level. Level 1, level 0, level 2. Right? Right. It's very easy. Depth 0, depth 1, depth 2. Siblings. Not only siblings, parents, siblings. And right, these have the same depths. If they have same depths, they can be called same level. In Korean concept, I'm going to use a Korean word. Say 학렬, right? So if you see the family tree, you see the same level, right? Even though that person might have much older, might be much older or much younger, but they might be at the same level, right? So that happens. Okay. Height of tree is from the bottom leaves, from the terminal nodes of these leaves, right, to the root. That's the height of tree. This height of tree is 2, right? And degree are like 4. So that's the number of the Gannex, number of Gannex, number of Gannex, number of Gannex, number of Gannex. These are 4, right? Equal to 4. So that's the thing. And I'm sorry, so it's so messy, so I'm going to clean this up. Size of tree. Size of tree is number of trees, right? Number of nodes, sorry, number of nodes. Here 1, 2, 3, 4, 5, 6, 7, 8. 8 nodes are here, and size is 8. And furthermore, fruit tree. Fruit tree is a tree that has the leaves have the same level, and at the same level, and with the full number of the nodes. It has a perfect triangular shape. If G is not here, it's not a full tree, right? Because then we have a missing element here, missing leaves here. It's always perfectly aligned, and that's being called full tree. And also, there is a term called complete tree. Complete tree shape is like this. Upper here, it should have full tree. And after having full tree, the last level filled in from left to the right. So for instance, this is a complete tree because it has a full tree here and DE filled in from left to the right. For instance, if we don't have E here, if we have E here, it's not a complete tree because that is incomplete tree, right? Because we don't have this node here. It's always full tree upper and filled from left to the right. Okay. After looking at this, after going through these characteristics, let's do some math. Let's do some algebra. Number of nodes. How many number of nodes? Actually, there is a very easy way to calculate this. Each node in tree structures have a edge to the from the parent. For example, E has a path to the an edge to the B. F has an edge to parent. G has an edge to parent. H has an edge to parent. B has an edge to parent. C has an edge to parent. D has an edge to parent. A does not have an edge to parent, except one node. Every node in tree structures has exactly one edge to its parent, right? So means that number of edges are equal to number of nodes minus 1, and 1 is coming from root, right? And depth of root is very easy. It's always going to be 0, right? And height of root is going to be height of tree. So This is the height of tree, right? Height of root is equal to height of tree. Having said that, maximum number of nodes at level I, level means like this, right? This is level 1, this is level 2, right? This is level 0. And maximum number of nodes at level I with degree D. How can you calculate this? It happens to have this D0, D1, and D2. Means that that's DI, right? It's going to be DI. And maximum number of leaves with height H and degree D. That's going to be leaves, number of leaves and height H. Means that it's going to be DH. The leaves are. So it's going to be DH, right? And having said that, maximum size. So we are all talking about maximum. It might not that number, but maximum number would be this, right? Maximum size of this tree structure with height H and degree D is what? Yeah, size is equal to D0 plus D1 plus plus D what? H. And because you are a smart student, you can do high school math, and it's going to be like this, right? So it's very easy, right? So it's high school math. Having said that, so I'm going to clean this up, right? Having said that, height of a complete tree with size S and degree D is the height of complete tree, tree structure with size S and degree D. How can you find out? Right. So it's going to be complete tree, so it's not a full tree, right? So it's not a maximum number. So S is going to be less than DH plus 1 minus 1 D minus 1. This maximum size of tree means full tree, right? So full tree's size is going to be like this. Because it's complete tree, it's going to be less than full tree size. So we can put a inequivalence here, right? And what you want to do is getting this H. Means we want to know H, right? We want to know this. And how can you do this? Actually, let's do a little math here. That's D minus 1 and DH plus 1 minus 1, right? And then we can move around as say D minus 1 plus 1, DH plus 1. What we can do here is that we can add log D here as D minus 1 plus minus 1 plus 1 H plus 1 because it's log D, right? And then what we can do here is that H, right? And then log D as D minus 1 plus 1 and minus 1, right? So it's high school math, and we find out this H. And because this inequivalence is coming from here, I'm going to put this thing here and minus 1 here, right? So, right. So it looks complicated, but it's simple high school math. You can do that. You can do this. I believe in you, right? It's easy. So we found out these trees characteristics.